Hey guys, hello, welcome back to the AI Explained series. I am so glad you are here. If you are watching this for the first time, welcome. And if you have been following along from part 1 and part 2, thank you so much for continuing this journey with me. Your support means a lot. So, in part 1, we covered what artificial intelligence is, how it started, the history, the different types of AI. In part two, we went deep into supervised and unsupervised learning, two of the most commonly used machine learning techniques. So, today in part three, we are going to cover the three most exciting and talked about topics in AI right now. These are the technologies that are making headlines every single week in newspapers, in tech companies, in government discussions, and in universities all around the world. So, let's get started. Part 1 is reinforcement learning, the technique behind AlphaGo robotics and how ChatGPT was made safe and helpful. Part 2 is generative AI, the incredible technology that can create text, images, music, videos, and code from scratch just from a simple instruction, isn't it? And large language models or LLMs, right? The powerful engines behind ChatGPT, Gemini, Cloud, and every other major AI chatbot. By the end of this video, you will not just know what these things are, you will understand how they work, what makes them special, how they are already changing the world around us. And as always, this video is made for completely beginners. And believe me, guys, I'm a mechanical engineer. No coding, no mathematics, just clear explanation, simple analysis, and real life examples. Yes. So let me quickly show you what we planned for today, right? As you can see on the screen, we have three parts. In the first part, reinforcement learning, we will understand how AI learns by doing, just like a child learning to walk by falling and getting up again. We will see how this technique is used to train robots beat world chess championship at chess and video games, manage energy in data centers, another example, and even how it was used to make ChatGPT safe. So, in the second part, generative AI, we will understand what makes this technology so revolutionary. Why can AI now write poetry, create realistic photographs, compose songs, and generate entire videos, all from a short text instruction? We will look at 9 of the most famous and widely used generative AI tools in the world. In the third part, large language models, we will open the hood and look inside. How does the ChatGPT actually work? What is a transformer? What is attention? And how GPT-4, Gemini, and Cloud compare to each other? We will answer all of this, right? Okay, let's jump straight into part 1, reinforcement learning. So, what is reinforcement learning? Let me give you the most intuitive explanation I can. Imagine you are teaching a dog to sit. What do? When the dog sits, you give it a treat. When it doesn't sit, or when it runs away, no treat. Over many repetitions, the dog learns sitting. When the owner asks, I get a reward. No, not sitting, no reward. The dog optimizes its behavior to get more treats. Reinforcement learning works exactly the same way. But instead of a dog, we have an AI model called an agent. And instead of a dog owner, we have an environment that gives rewards and penalties based on the agent's action. Let me explain the four key components you see on the slide because these four words are used in every reinforcement learning paper and every reinforcement course in the world. Number one, the agent. This is the AI model, the learner, the decision maker. It is one of that take actions. It could be a robot, a game playing AI, a self-driving car, or a recommendation system. Number two, environment. The environment. This is the world that agent lives in, interacts with. For a chess AI, the environment is the chessboard. For a robot, the environment is the real world or a simulation of it. The environment gives the agent information about its current situation. Number three, action. The action. At each step, the agent looks at its current situation and decides what to do. Move left or right, attack or defend, speed up or brake. Every decision is an action. Number four, the reward. After every action, the environment gives the agent a feedback signal saying a reward. It could be +1 for a good action, -1 for a bad action, or 0 for a neutral action. The agent's entire goal is to collect as much reward as possible over a period of time. So the learning loop is this. The agent observes the environment. It takes an action. It receives a reward. It updates its strategy based on that reward. Then it repeats millions of times and it gets really, really, really good. So let's thinking of a child learning to walk. Falls down, that's a penalty. Takes a step without falling, that's a reward. Over thousands of tries, the child learns to walk, right? No teacher needed, just trial and error based method and rewards signal. The reinforcement learning loop. Now let's look at the complete learning loop, the cycle that makes reinforcement learning work. Okay, it works like this. So the first step, the agent looks at the environment and gets the information about the current state. For a chess AI, the state is the current board position where all the pieces are. For the self-driving car, the state is what the cameras and sensors are seeing right now. The next step, based on that state, the agent uses its policy to decide what action to take. A policy is basically the agent's strategy, a set of rules that maps what I see to what I should do. In the beginning, the policy is random. The agent has no idea what it's doing, but over time it gets smarter. The next step, the agent takes action, the environment responds. A new state is shown to the agent, and critically, the agent receives a reward signal. This reward tells the agent that was a good move, well done, or that was a terrible move, don't do that again. So, the last step, the agent updates its policy. It uses the reward signal to adjust its internal parameters. This action I took in the situation gave me a good reward. I should do that more often. This update is the learning part. And then it loops back to the step one. The agent observes that new state, takes a new action, gets a new reward, updates, repeat millions of times. What is remarkable about this is actually the agent doesn't need to be told what the right strategy is. Nobody gives a rule book. It discovers the optimal strategy entirely by itself through experience. For instance, Google DeepMind's AI was given access to cooling controls in a data center, thermostats, fans, coolants. No human told it what the right setting were. The reward was use less electricity while keeping temperatures safe. Within weeks, it found strategies humans had never thought of, reducing cooling energy use by 40%. Let's talk about reinforcement learning in the real world examples. Okay. In 2016, Google DeepMind built an agent called AlphaGo, trained using reinforcement learning, and it defeated the world's best Go player, Lee Sedol. Now, Go is not chess. Go has more possible board positions that there are atoms in the observable universe. No computer had ever beaten a top human player before. How did AlphaGo learn? By playing millions of games against itself in simulation 24 hours a day. Every time it won a game, reward. Every time it lost, penalty. So, after enough self pay, it developed strategies that no human had ever thought of. It played moves that even the old champion described as beautiful and not human like. Similarly, OpenAI built an AI called OpenAI 5 that defeated the old champions at Dota 2, a complex real time strategy video game. It had to learn to cooperate with four teammates, plan long term strategies, and respond to unpredictable opponents, all through reinforcement learning only. These achievements showed the world that RL can master any problem, not just simple games. In fact, complex, strategic, long origin changes. Robotics. This approach is called, Boston Dynamics robots, the ones that can do backflips, climb stairs, open doors, and even dance, are trained using reinforcement learning. The robot is placed in simulation where it tries to walk, it falls, penalty. It takes a step, reward. Falls again, penalty. Over millions of simulation attempts, it learns to walk smoothly, then run, then jump. This approach is called sim to real transfer. Train in cheap simulation, then deploy in the real world. It saves enormous amounts of time and money because a physical robot getting trained by falling down a thousand times a day would break very quickly. Self driving cars. Waymo, Google's self driving car company, uses reinforcement learning to teach its cars how to handle complex real world driving scenarios. This car is rewarded for safe driving, staying in lane, following speed limits, yielding to pedestrians. It is penalized for near misses, hard braking, and traffic violations. Over billions of simulated miles, the car learns to drive better than most humans. ChatGPT and reinforcement learning from human feedback. This is perhaps the most important application of reinforcement learning for most people today. ChatGPT, the AI assistant used by hundreds of millions of people, was fine tuned using a technique called RLHF. Like I said, I'm repeating again, RLHF stands for Reinforcement Learning from Human Feedback. Here is how it worked. First, the GPT model was pre-trained on a massive amount of internet text, but at the stage it was just a text predictor. It would say whatever most likely, even if it was harmful, biased, or unhelpful. The OpenAI used RLHF. Human trainers were shown pairs of GPT responses and asked which one is better, more helpful, more honest, more safe. Their ratings were used to train a reward model, an AI that learned to predict which responses human would prefer. The GPT was fine tuned using this reward model, trained to produce responses that the reward model predicted humans would rate highly. This is what made ChatGPT helpful, safe, and conversational instead of just random and unpredictable. Example, so the next time if you like ChatGPT gives a clear, polite, structured answer, this is not just language modeling, this is reinforcement learning from human feedback at work. So, moving to what is generative AI. Generative AI is a type of artificial intelligence that can create new original content, text, images, audio, video, code, and more that has never existed before. It learns the patterns in existing data and generates brand new data that looks just like it. All right. So there are basically two types. We are going to talk about traditional AI and generative AI. So the traditional AI, the kind we talked about in part two with supervised versus unsupervised learning, right? Is mostly about analyzing existing data and drawing conclusions. Is this email spam? Is this tumor cancerous? Group these customers into segments. It takes in data and makes a decision about that data. Generative AI is completely different. Generative AI generates brand new content that has never existed before, not just analyzing, actually creating. Think about what that means for a moment. You give a generative AI system a simple instruction called a prompt, and it produces something new. You say, write a poem about monsoon rains in Hyderabad or Bangalore, and it writes a beautiful original poem. You say, generate a realistic photograph of an astronaut riding a horse on Mars. Okay, and it creates that image. You can say even compose a 3 minute song in Telugu about friendship, and it generates that song with vocals and instruments. How is this possible? Generative AI learns the underlying patterns in a massive amounts of existing human created content, books, articles, images, music, code, and then learns to generate new content that follows those same patterns. It doesn't copy, it creates. This is what makes generative AI so revolutionary. So, and importantly, the quality of what it creates is extraordinary. In many cases, it is incredible again from human created content. So, in 2023, a piece of music generated by AI was submitted to a competition without judges knowing. It won a first place. The judges were shocked when they found out. This is the power of generative AI. So, what can generative AI create? Let me show you just how broad and powerful generative AI is. Because this technology doesn't just create one type of content, it creates almost any type of content. First, text. This is the most mature category. AI can write articles, blog posts, emails, legal documents, exam questions, social media captions, product descriptions, stories, scripts, and summaries. Tools like ChatGPT, Cloud, and Gemini do this. If you have ever used ChatGPT to write something, you have used text based generative AI. Second, images. Tools like DALL-E, Midjourney, and Stable Diffusion can generate completely realistic, high-quality images from a text description. A photo of golden Lebret sitting in a coffee shop in Paris wearing a beret, and it creates a stunning photorealistic image of exactly that. Nobody photographed it, nobody painted it, that the AI created it. Third, music and audio. Tools like Suno AI and Udio can generate full songs with lyrics, vocals, instruments, and mixing in any style and genre. You type, create an upbeat Telugu folk song about harvest season, and in 30 seconds, just 30 seconds, you have a complete song. And video. This is the newest and most jaw-dropping category. The OpenAI Sora can generate 60-second HD video clips from a text prompt. A panda walking through a neon-lit Tokyo street at night, cinematic style, and it generates a realistic, beautiful video. This used to require a film crew, actors, locations, and months of editing. Now it takes seconds. In fact, maybe sometimes milliseconds also. Fifth, code. Tools like GitHub Copilot can write complete functions, fix bugs, and even convert code from one programming language to another. Maybe it can be Java from Python to Java, C to C plus, C++ to Python, anything for that matter. Studies show developers using GitHub Copilot are 50% faster than those without it. And scientific data, lastly, AI can even generate new drug molecules, predict protein structures, and create synthetic data sets for training other AI systems. So, example, when the movie The Beatles Now and Then was released in 2023, it used AI to restore and enhance John Lennon's voice from low quality cassette tape recorded in 1970s. That was generative AI bringing a voice back to life. How does generative AI work? Now the big question, how does generative AI actually work, right? How can a computer system create something that feels genuinely creative? Let me explain four steps. The first step, training on massive data. The model is fed an enormous amount of existing human created content. For a text model, that means billions of web pages, books, research papers, Wikipedia, code repositories, and more. For an image model, it means hundreds of millions of images. The model studies all of this and learns the patterns, relationships, and structures within the data. The next step, building internal understanding. As the AI model trains, it builds a compressed internal representation of all that knowledge stored in billions of numerical parameters. These parameters encode the model's understanding of language, concepts, facts, styles, and structures. This is the model's brain. The next step, receiving a prompt. When you type a prompt, write a poem about rain. The model converts your words into numbers, processes them, and begins the generation process. So the next step, generating one piece at a time. Here is the really interesting part. The model does not plan the entire poem in one go. It generates the output one small piece at a time, one word, one token, based on everything that came before. It predicts. Given the prompt and the words I have generated so far, what is the most likely next word, then it picks that word, then predicts the next one, and so on until the poem is complete. This process is similar to your phone's autocomplete, but on a scale, this is billions of times more sophisticated. Your phone's autocomplete predicts the next word based on a few words of context. Generative AI predicts the next word based on billions of documents of training and all of the context in the conversation. For example, when you ask ChatGPT explain quantum physics like I am 5 year old, it doesn't look that up in a database. It generates a brand new explanation in real time, word by word, based on what it learned during training. So moving to next slide. Famous generative AI tools you must know, right? Now let me introduce you to the most famous and widely used generative AI tools. These are all the ones you will encounter in your work, studies and daily life if you haven't already. First, ChatGPT by OpenAI. Launched in November 2022, it reached 100 million users in just 60 days, making it the fastest growing consumer application in history. Faster than Instagram, faster than TikTok. It can answer questions, write essays, translate languages, explain complex topics, write and debug code, and much more. If you want to start with one AI tool, start here. So DALL-E, also OpenAI. This is also text to image generator. It powers Bing image creator, which is free to use. Just try what you want to see and it generates it. Third, Midjourney. This is what professional designers and artists use. The image quality is stunning, cinematic, aesthetic, highly detailed, widely used in advertising, game design, and film production. Fourth, Gemini. By Google DeepMind, Google's answer to ChatGPT. What makes Gemini special is that it is multimodal. It can process and generate text, images, audio, and video. It is integrated into a Google Research, Gmail, and Google Docs. Cloud. By Anthropic design to be helpful, harmless, and honest. Cloud is particularly good at reading and summarizing very long documents, up to 2 lakh words in a single conversation. Widely used by researchers, lawyers, and analysts. Actually, the cloud using to help make this script. Sixth, Sora by OpenAI. This was released in 2024 and it shocked the world. Sora generates high quality 60-second videos from a text description alone. The quality is so realistic, it's hard to tell it from real footage. Then, stable diffusion. Unlike the others, this is open source, meaning anyone can download and run it for free on their own computer. Very popular with developers and researchers. Eighth, GitHub Copilot. This is an AI coding assistant built into code editors. It was trained on billions of lines of code and can suggest entire functions as you type. Microsoft reported that developers using Copilot complete tasks 50% faster. And 9, Suno AI. This tool can generate complete songs with lyrics, vocals, melody, instruments from a simple text prompt. An upbeat pop song about learning AI, and in 30 seconds, you have a full song. Fun fact. So, in 2024, a song called Heart on My Sleeve was generated by AI using vocal style of Drake and The Weeknd. Without anyone's permission, it went viral with millions of streams before being removed. This shows both the incredible power and the serious ethical challenges of generative AI. So we are moving to LLMs. What is large language model? So we have covered reinforcement learning and generative AI. So yeah, the final topic, large language model. So you have heard this word, right? LLM everywhere. But what does it actually mean? So let's break it down. Large means the model has enormous number of parameters. Parameters are like the model's memory, numerical values that store what the model has learned. GPT-4 is estimated to have around 1.8 trillion parameters. This has 1800000000 numbers. For comparison, the human brain has about 100 billion neurons. GPT-4 has 18 times more parameters than there are neurons in the human brain. Language means the model is specifically designed to understand and generate human language. It learns from text, it processes text, it generates text. Every interaction with it is neutral, sorry, natural language, no coding required. Model means it is a mathematical model. Under the hood it is very large neural network, billions of connected mathematical operations that transform your input into an output. So, an LLM is essentially a very large neural network trained on an enormous amount of text data that can understand and generate human language at a level that was previously thought impossible for computers. So, to give you a sense of the scale, GPT-4 was trained on an estimated 45 terabytes of text. This is equivalent to around 15 million books. All of Wikipedia is less than 1% of that training data. The training cost OpenAI approximately 100 millions US dollar and required thousands of specialized GPU chips running for months. So, for example, when a fresh medical graduate passes their exam, they have read thousands of textbooks and case studies. GPT-4 has read the equivalent of millions of books. This is why it can answer medical questions, legal questions, coding questions, and philosophical questions all in the same conversation. How do LLMs work? The transformer. Okay, now how, what is the technology inside them? This comes down to a revolutionary architecture called transformer. The transformer was invented by Google researchers in 2017 and published in a famous paper called Attention is All You Need. That paper changed the course of AI completely. Before the transformer, language models were limited in what they could do. After the transformer, everything changed. GPT, Gemini, Claude, Llama, they are all built on the transformer architecture. So let me explain the four most important concepts inside a transformer. Okay, token station. When you type text to an LLM, the first thing that happens in your text is split into tokens. Tokens are small chunks of text. Usually, words are parts of words. For example, ChatGPT is amazing. Might be split into tokens like chat, comma G, comma PT is, amazing. Each token is converted into a number. The model only works with numbers, not words. Embedding. Each token number is then converted into an embedding, a vector, which is a list of hundreds or thousands of numbers. This vector captures the meaning of the word. Words with similar meanings have similar vectors. For example, the vectors for king and queen are similar. The vectors for dog and cat are similar. And there is a famous demonstration. If you take the vector for king, subtract the vector for man and add the vector for women, you get a vector that is very close to queen. The model has learned gender relationships purely from reading text. The attention mechanism, the key innovation, in fact. This is the most important idea in the transformer. It is called self attention, and it is what makes LLMs so good at understanding language. Here is the problem it solves. Consider the sentence: the animal didn't cross the street because it was too tired. What does it refer to, the animal or the street? You know it's the animal because you understand context. But how does the model know? The attention mechanism allows each word to look at every other word in the sentence and decide how relevant each word is for understanding its own meaning. When processing the word the attention mechanism gives high weight to animal and low weight to street. So the model correctly understands that it refers to the animal. This is revolutionary because it allows the model to handle long range dependencies in text, understanding how words far apart in a sentence relate to each other. Previous models could not do this well. Next, token prediction. Finally, LLMs are trained to do one simple task. Given all the words that came before, predict the next word. That is it. But this simple task, done billions of times on trillions of words, forces the model to develop deep understanding of language, facts, reasoning, and even coding. Predicting the next word requires understanding the whole context of what came before. Every time you ask ChatGPT a question, it generates its response one token at a time. The capital of France is, let's say, immediately it identifies Paris. It doesn't search in database. It predicts Paris as the most likely. Moving to next slide. Top LLMs compared. All right, so let's look at the big LLMs that are dominating the industry right now and understand how they compare. First, GPT-4 by OpenAI, which is the most widely used LLMs in the world. It is estimated to around 1.8 trillion parameters. It is excellent at general tasks, coding, reasoning. Second, Gemini Ultra by Google DeepMind. This is the Google's most powerful model. What makes it unique is that it was designed from the ground up to by multi-model. It processes text, images, audio, and video all together. Its context window is 1 million tokens, meaning it can read and process a book of over 7 lakh words in a single conversation. Extraordinary. Third, the Cloud 3.5, Sonest by Anthropic. Cloud is known for being particularly good at reasoning, long document analysis, and following complex instructions safely. It has a context window of 2 lakh tokens, good for reading and summarizing very long documents. It is the preferred choice for many businesses and researchers. Llama 3 by Meta. This is the most important open source LLM available. Meta made it free to download, modify, and run on your own hardware. The 405 billion parameter version is competitive with GPT-4 developers, researchers, and companies who want full control over their AI without paying per API call. Use Llama. The landscape is changing incredibly fast. Every few months, a new model breaks records. What is true today may be outdated in 3 months. The key is to understand the concept, then you can quickly adapt as the specific tools change. Yes. So GPT-4 charges about 5 billion, 5 per million input tokens. Llama 3, if you run it yourself, costs only the electricity. For companies making millions of API calls, that cost difference is enormous. This is why open source LLMs are so important for startups and research. So what can you do with LLMs? So now we so that we know how LLMs work, let's look at what can you actually do with them. So one, conversational AI and customer support. Okay, companies are building AI chatbots using LLMs that can handle complex customer queries, processes refunds, answer product questions, and escalate to humans only when needed. So Shopify, Airnab, and dozens of Indian companies already using this at a scale. So secondly, code generation and debugging. GitHub Copilot powered by OpenAI and write codes as you type. Studies show it writes approximately 46% of all code in projects where it is used. Developers it to write use it write and code, fix bugs, write tests, and convert code between programming languages. It is like having a senior developer sitting next to you. So third, document summarization and analysis. Law firms use LLMs to read 200-page contracts and extract key clauses in minutes. Hospitals summarize patient records, researchers summarize scientific literature. What used to take these days now takes seconds. For language translation, LLM based translation tools now produce translations that rival professional human translation for most language pairs. This is opening access to information for billions of people who don't speak English. So, five, education and tutoring. Okay, Khan academies tutor student individually using LLMs, answering questions, explaining concepts in different ways, giving hints without giving away answers. Every student gets a personal tutor. Lastly, scientific research. Scientists are using LLMs to read thousands of research papers, summarize findings, identify gaps, and even suggest new hypotheses. DeepMind's AlphaFold, which used AI to predict protein structures, has accelerated drug discovery by decades. So now let's take a moment to put all three topics together and show how they relate to each other, because many people including me get confused between them. Reinforcement learning is a learning method. It is technique for teaching to AI to make decision by trial and error, rewarding good actions and penalizing bad ones. It is used to train game playing AIs, robots, self-driving cars, and to fine-tune language models. Generative AI is a category of AI. It refers to any AI system that can create new content, text, images, audio, video, code. It is defined by what it does, generate, no, not by how it is built. LLMs are specific type of Gen AI. They are the most powerful and widely used to type of generative AI for text. They are built on the transformer architecture. So how do they connect? LLMs are subset of Gen AI, and reinforcement learning is one of the techniques used to train Gen AI models. Specifically, the RLHF technique used to make ChatGPT, Cloud, and Gemini safe and helpful. Think of it this way. If GenAI is restaurant, LLMs are the kitchen, and reinforcement learning is one of the cooking techniques used in the kitchen. They work together to create the final product we use. ChatGPT in one sentence. So it is an LLM architecture, which is a type of Gen AI category fine-tuned using reinforcement learning method. So what we learned today, let's as a summary, let's discuss. All right. So the four most most important things we should walk away with after watching this video, right? Reinforcement learning. This is when an AI learns by trial and error, getting rewards for good actions and penalizing for bad actions. The four key parts are the agent, the environment, the action, and the reward. It is used in game playing, AI, robotics, self-driving cars, and to make ChatGPT helpful through RLHF. So the second key takeaway, generative AI. This is AI that creates brand new content, text, images, music, video, code, and more. It learns patterns from massive amounts of existing content and generates new content following those patterns. Famous tools like ChatGPT, Dynamic Journey, Gemini, Claude, Sora, and GitHub Copilot. So the third key takeaway, large language models. These are massive neural networks with billions of to trillions of parameters trained on enormous amounts of text. They are built on the transformer architecture and use the attention mechanism to understand language deeply. They power all major AI chatbots. Key models are GPT-4, Gemini, Cloud, and Llama. The fourth key takeaway, how they connect. LLMs are a type of generative AI reinforcement learning, specifically RLHF. It is used to train and fine-tune LLMs. Together, these three technologies power almost every major AI product in the world today. So we are going to talk about prompt engineering and other aspects like augmented generation agents. These are all the practical skills you need to actually use and build with these AI techniques. So make sure you don't miss it next video. So, and that is a wrap. We covered a lot. Like I said, it sound like overwhelming. Uh, Three of the biggest topics in AI all in one place. I hope it was clear. I hope it was interesting, and most importantly, I hope it gave you a much better understanding of the AI world around us. Every single day, these technologies are being used in the apps on your phone, the website you visit, your product you buy, and the services you use. Understanding them, even at a basic level, puts you ahead of 90% of the people around you. If you made it all the way to the end, thank you so much. Genuinely, thank you. That tells me that this content is valuable to you, and that makes it that makes all the effort worth it. So if this video is helpful, please give it a thumbs up. Thank you. Finally, if you know someone who is curious about AI, please try to share this video, who wants to understand what ChatGPT, how it works, how it can do. So yeah, so finally, thank you so much for watching. You're amazing. Take care and keep learning. See you in the next video. Thank you guys.